Okay, we are still in the log unit. Again, not actually, it's not unit 9, but today we are actually going to be solving exponential equations using logs to help us do so. So our topics again, yay, the log song. It doesn't go away. We're not done with this unit yet. Then we are going to solve exponential equations, review it where you don't have to use a log, just to kind of get us back into the feel of those problems from our last unit. And then we'll actually jump into using logs in order to solve exponential equations. So we'll talk through all of that as we get there. Here's our log song. Come on, log song.
One rolls downstairs, over and there, rolled over your neighbor's dog. Let's wait for a snack and sit on your back. It's log, log, log. It's log, log. It's big, it's heavy, it's wood. It's log, log. It's better than that, it's good. Everyone wants a log. You're gonna love it, log. Come on and get your log. Everyone thinks a log.
Log from Blammo.
All right, there's our log song. Let's move on to this next lesson, next content. Exponential equations. They always have a variable in the exponent position, and we have to move that variable out of that position kind of like down to the normal level or as a base so that we can solve for that variable. We've got two ways to do this, by making the bases the same and solving for the exponent. We did that in our exponential unit, and we've got good practice with that. We're going to hit it again just to make sure. And then our new thing is to take the log of both sides and actually solve the equation. So quick recap, solving exponentials that have the same base. Remember, these we've been basing our solving logs with the same base using these same properties. So if I have the same base, I can just drop the base and set those exponents equal. So 5 to the 3 minus r equals 5 to the 2r plus 1. The bases are identical, which means that the exponents should be equal to one another as well. So we can very easily solve by combining our like terms across the equal sign and then getting that variable all by itself. So you'll notice I've added r to both sides of the equation. So I have 3 equals 3r plus 1, and I'm subtracting 1 from each side of the equation to get 2 equals 3r. And when we divide, we get r to equal 2/3. Just leave it as a fraction. No reason to put it in the calculator. That's great. It works. Example 3 that we have, 2 to the power of negative r equals 2 to the 5th. Gosh, this one's even easier than the last one. So negative r equals positive 5. Therefore, r equals negative 5. Make sure you divide or multiply by negative 1. You don't have to show the stuff if you don't need to. All right, example 4, a little bit beefier. I have 81 to the power of 2n equals 27 to the power of n. We need these guys to be the same base. I know that 9 squared equals 81. But 9 to the 3rd is going to be even bigger. That's not going to give me a 27. Okay, so let's think smaller. How about a base of 3? 3 to the 1st is 3. 3 squared is 9. If I multiply that by another 3, 3 to the 3rd is 27. Okay, cool. So I got that guy. If I multiplied that 27 by 3 again, so 3 to the 4th would give me 81. So in this case, I need to rewrite both of these bases to have a base of 3. 81 is 3 to the 4th. That 4 gets multiplied by the power that's already up there. Equals 27 to the n. So 27 is 3 to the 3rd multiplied by the power or the exponent that's already there. Now we have the bases the same. Kick it to the curb. Set our exponents equal. 4 multiplied by 2n equals 3 multiplied by n. So 8n equals 3n. No matter how you solve this, you will get that your n value will equal 0. So 81 to the power of 0 equals 27 to the power of 0. Anything in the world, you guys, to the power of 0 equals 1. So yeah, that one definitely works. Good deal. Example 5, 125 to the power of 3x equals 25. And that is 25 to the first power if you want to see it. I can't do 25 squared. That does definitely not equal 125. But I know that 5 squared equals 5 squared equals 25, and 5 to the third power would equal 125. So I can rewrite 125 as 5 to the third, multiply it by the power that's already there, equals 25 I can rewrite as 5 to the second power. Once the bases are the same, we kick them to the curb and multiply our exponents. 3 by 3x to give me 9x, and that equals the other side, which is just 2. So 9x equals 2, and when we divide, we get x to equal 2/9. Perfect. Absolutely love it. Okay, now we're going to have some examples that we cannot rewrite each of these bases, these exponentials, to have the same base. There is no way I can write 81 as having a base of something equaling 79 having the same base. There's no way to do that. So what we can do is we get to use log base 10. You can also use the natural log if you'd like, but most of the time we just do log base 10 because it just means log of that value, okay? In order to get the exponent out, I need to do log of something. Remember when we exponentiated and I had 5 to the power of log base 5 of x? 5 to the power log base 5 would undo itself and just leave me with that exponent up there, that argument piece, and it would give me what I need. We're going to do the same thing with these. So if there's no way to make those exponential bases or the bases of the exponentials the same, I'm going to do log of 18 to the power of n equals log of 79. Okay, I have done a log on both sides of the equation. Whatever I do to the left, I got to do to the right. Now I can use my power property because I have the left-hand side with log base 10 of 18 to the n. So the n can come out front, and that gets multiplied by log base 10 of 18, which equals log base 10 of 79. Now that I have it written as a coefficient being multiplied, the n times log of 18, I can divide through by that value. Don't type anything into the calculator till you're done. Like, why do it multiple times? When I divide both sides by log of 18, I isolate the n, and that will equal log of 79 divided by log of 18. This you can now type into your calculator because that's written with the change of base formula, and they're already both in base 10. And we're going to estimate, this tells us to round to the nearest hundredth, so that would be the second decimal place. And I have 1.511, so this would round in is approximately 1.51. Okay, that's as basic as they get. There are other steps that you can take, but what we're going to do is isolate the terms, the bases with your exponent, get them as isolated as you can, and then take the log of both sides. So log base 10 of both sides. Let's practice a few more of these. 14 to the power of n plus 6, extra little chunk there, equals 85. There's no way to make 14 and 85 have the same base. So I'm going to do log of 14 to the power of n plus 6 equals log of 85. Okay, remember, power property, that whole thing, the n plus 6 is all going to be multiplied. So n plus 6 multiplied by log of 14 equals log of 85. Okay, you'll notice I kept that exponent in parentheses. Those two guys are all married together right now. Now I can divide both sides of my equation by log of 14 to isolate that argument piece, the n plus 6. So now I have n plus 6 equals log of 85 divided by log of 14. In this case, if you like, you can go ahead and type that into the calculator and then subtract 6, or you can wait and you can type in log of 85 divided by log of 14, put that in parentheses just to be safe, and then subtract 6 at the end. That will give you the most precise answer, unless you just do log of 85 divided by log of 14, press enter to get that number, which is approximately 1.6834. And then if you subtracted 6 after it, you would get your end value to be approximately negative 4.3165. So we would round that to negative 4.32 is our value for n, rounded to the nearest hundredth. All right, hopefully you guys are doing okay with these. I'm going to try to keep it at a little bit slower pace to make sure you're getting these down pat. Oh, that was the last one. I thought we had more. Again, sorry, the dates on these are not correct. You've already done quiz 1. Quiz 2 is coming up. Test is after spring break. And again, you guys make sure you're really hitting these hard on worksheet E. We'll have more practice in class as well. Hopefully you did well. Catch you next time.